Hey guys, so we're moving on to 3.5 today. So today we're going to be able to fit a function to linear data shown in a scatter plot and then use that function to solve problems. We're also going to interpret the slope of a trend line for a story problem. So this is 3-5 scatter plots and lines of fit. If you guys have seen scatter plots before, okay, you just got a bunch of points and you plot them, okay, and they're kind of scattered all over the place. We're going to look at some that have a relationship in them. So here's our first graph. Okay, it's temperature after sunrise. Okay, notice our x-axis is hours after sunrise, and the y-axis is the temperature. So what is the relationship between the hours after sunrise and the temperature shown in the scatter plot? So what's happening? Okay, as our hours after sunrise increases, what's happening to our temperature? Well, the temperature is generally increasing over time. Okay, notice we're going uphill. So as the number of hours after sunrise increases, so does the temperature. So when y values tend to increase as x values increase, we say that the two data sets have a positive association. Okay, this would have a positive association because the slope is going uphill. Okay, another example. Notice this time is temperature after sunset. So what's the relationship between the hours after sunset, which is x, and the temperature y shown in the scatter plot? Well, okay, as time goes on, so as our hours after sunset increases, our temperature is coming down. Okay, temperature is generally decreasing over time. Again, as the number of hours after sunset increases, our temperature decreases. So when y values tend to decrease as x values increase, we say that the two data sets have a negative association. Okay, notice the line is going downhill, negative. Okay, rainfall after sunset. What is the relationship between the hours after sunset, x, and the amount of rain, y, shown in the scatter plot? Well, those dots are everywhere. So is there a relationship? No, there's no general trend in this data. And there is no relationship between the amount of rainfall and the number of hours after sunset. Okay, so when there is no general relationship between x values and y values, we say that the data sets have no association. Okay, so here's two problems to try. Pause the video and to tell me what type of association letter A has. Okay, well, if I'm looking at letter A, I'm noticing these points are going uphill, so we say this has a positive association. Pause the video and try letter B, please. Okay, I'm looking at letter B, dots are everywhere, so therefore this has no association. All right, so the next thing we're going to talk about is correlation. Okay, notice the word related in there. So how can the relationship between the hours after sunrise x and the temperature be modeled? Okay, well, we said this has a positive association earlier. So notice also they kind of approximate a line. So to figure this out, we're going to sketch a trend line that best fits the data to determine whether a linear function can model this relationship. Okay, so a trend line is a straight line going through this, or as we learn other types of graphs, it might be a quadratic, it might be something else, that kind of most closely matches the data. So if I draw this straight line in here, the goal is to try and get in between the points. So I kind of want half the points above the line, half the points below the line. So this trend line suggests that a linear function could model the relationship. Okay, it's really good down here. Not as good up here, but it's still not too terrible. Okay, so since the scatter plot suggests a linear relationship, we say there's a positive correlation. Okay, positive correlation because the line's going uphill. It has a positive slope. When data with a negative association are modeled with the line, we say there is a negative correlation. Okay, negative because the slope is going downhill. If the data do not have an association, then we cannot model it with a linear function. Okay, so try it number 2. How can the relationship between the hours after sunset X and the temperature Y be modeled? If the relationship is modeled with a linear function, describe the correlation between the two data sets. Please pause the video and try this. Okay, so first thing when we are trying to figure out if this can be modeled by anything, we want to see if we can get a line that kind of looks, does it look like a straight line? Well, if I kind of draw a line through here, yeah, I'm pretty close to most of those points. So this can be modeled with a linear relationship. Okay, and since it can be modeled with a linear function, what kind of correlation does this have? Well, my line's going downhill, so this has a negative correlation. So what trend line models the data in the scatter plot? Okay, this is where we're actually going to calculate the equation of that line. So a trend line models the data in the scatter plot by showing the general direction of the data. Okay, a trend line fits the data as closely as possible. So we have a couple steps in order to find these trend lines. The first thing we want to do is to sketch a trend line for the data. A trend line approximates a balance of points above and below the line. Okay, so you want to try and get the same number of points above the line as you have below. Okay, it's very important to note that the trend line might not pass through any of the points you actually have. Okay, notice our blue line barely touches any of those red lines, the red dots. It's perfectly allowed. Okay, so you just try to get as close to as many of those points as possible. Okay, so this problem is really nice because they gave you the points. So step 2, we're going to write the equation of the line. So we're going to select 2 points on the trend line to find the slope. Then we're going to do y equals mx plus b. Okay, we spent a lot of time in chapter 2 doing this, so you should be pros at this by now. Okay, so the 2 points they gave us were 250 and 16,500. Okay, so as a reminder, slope equals m equals y2 minus y1 over x2 minus x1. Okay, so label our points x1, y1, x2, y2, and we just plug and chug. So y2, 500 minus 50 over 16 minus 2. 500 minus 50 is 450 divided by 14. Give me just a second. 450 divided by 14 is equal to, we'll go to 32.14. Okay, and it's not going to be pretty because this is real life stuff. Okay, so now that I have my slope, I'm going to do y equals mx plus b. Which point do you like better? I like the smaller number, so I'm going to use 2 and 50. And I know that m is equal to 32.14. Here's x, here's y. So let's plug and chug. So instead of writing y, I'm going to write 50 equals m. Okay, so that's 32.14 times x, and we don't know b, so I'm going to leave b alone. So let's do some calculating. 50 equals, let's see, it's 64.28. We're going to subtract this to get b by itself. And we get negative 14.28. So my line is y equals 32.14x minus 14.28. This is my trend line. All right, so here's one for you to try. Okay, what trend line in slope-intercept form models the data of the scatter plot? Okay, so how about this? I will draw a line in there for you because it's really going to be hard to pick points, especially when you don't have this. So that looks about even to me. Okay, so if I give you the point, let's see what's on the line that could be nice and pretty. How about right here? We'll call that the point 466. And this point right here, we'll call that 860. Okay, pause the video and find the equation of that line there. Okay, so first thing we have to do is find m. So y2 minus y1. So 60 minus 66 over 8 minus 4 is equal to negative 6 over 4, which is equal to negative 3/2. Okay, pick a point you like better. It doesn't really matter. So y equals mx plus b. I'll use this point. So 66 equals negative 3 over 2 times x, which is 4, plus b. 66 equals, let's see, negative 6 plus b. B equals 72. So based on the line I drew, you'll have the equation y equals negative 3/2 x plus 72. What do we think? Does that match? Well, our slope's negative, line's going downhill, so that's okay. 72 is what we got as our y-intercept. Look at that, goes to right about 72. So that matches. Okay, so let's think about why could there be no data points on a trend line, yet the line models the data? Okay, remember, a trend line just tries to get as close to those points as possible. Okay, it really doesn't matter what the points actually are. We care about where the line is. Okay, so it could still model because it's an approximation. Okay, so let's interpret some trend lines. The table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long will it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? Well, first step, we need to make a scatter plot. Okay, so remember, scatter plot, you would do your XY axis, and then you just plot the points. Okay, so they were kind enough to do that for us. Okay, the red dots are each of these points right here. Okay. Oh, look at that. They were nice enough to sketch a trend line for us as well. Okay, notice their trend line barely hits any of those dots, and that's okay. Okay, we don't care about the red dots, we care about the blue line. So step 2, we need to find the equation of the trend line. Okay, so I know my points are 40, 6 and 55, 4. So let's find the equation of that line. First thing we need to do is find m. So x1, y1, x2, y2. Okay, so m equals y2, so 4 minus y1 over x2 minus x1. So that's equal to negative 2 over 15. So there's our slope. Okay, which point do you guys like better? This one looks good to me. So y equals mx plus b. Y is 6. M was negative 2 over 15. X was 40 plus b. 6 equals, let's just throw that in the calculator, negative 2 over 15 times 40. Decimal, we'll get negative 5.33 plus b. So we're going to add 5.3 to both sides. B equals 11.33. So my equation is y equals negative 2 over 15x plus 11.33. Okay, now normally we would be done here, but the problem wants us to predict what the y value is when x is 75. Okay, so notice we want to know internet speed is 75. So how much time would it take? So we plug in 75 for x. Okay, so y equals negative 2 over 15, but instead of writing x, I'm going to write 75. Okay, so let's do some calculations. Negative 2 over 15 times 75 is equal to negative 10 plus 11.33. So y equals 1.33. So if my internet speed is 75, it'll take about 1.33 seconds to download. Okay, so that's time. Okay, number 4. What's the x-intercept of our trend line? And is this possible in a real-world situation? Okay, please pause the video and try this. Okay, so how do we find the x-intercept? Well, remember standard form, find the x-intercept, you let y be 0. So let's plug in 0 for y. So 0 equals negative 0.13x plus 11.2. Okay, so we're going to obviously subtract the 11.2. So So negative 11.2 is equal to negative 0.13x. We divide by that negative 0.13. So 11 divided by 0.13. We get x equals 86. Okay, so this tells me the point 86, 0. Okay, so let's flip back to see what x and y were. X is the internet speed, so the time to download. So we had 86, 0. So if my internet speed is 86 kilobytes, is it going to take 0 seconds to download? Or, I'm sorry, 0 minutes. I was reading that wrong. Oh, no, that doesn't really make sense. Okay, 0 minutes. Okay, so it's okay if your x-intercept and your y-intercept don't make sense. In the real world, usually we're only working with positive numbers. So when we start getting close to 0 and going across to negatives, it doesn't make a lot of sense, okay? But we can still use mathematics to work with the positive realm. Okay, so to summarize, remember we can have a positive association or a negative association that turns into a positive correlation or a negative correlation. Okay, you also can have no correlation. Everything else then is just y equals mx plus b. Homework tonight, page 124. You're going to do problems 9 through 12, 15 through 21 odd. Okay, not a ton of problems, but it'll be enough to keep you busy. Remember, come with questions. See you guys later.